A limit that tends toward infinity is when the approach statement in the limit has the infinity symbol in it. That means if it's positive infinity, we want to know what happens to the function as it keeps going forever to the right. And if it's negative infinity, we're checking what happens to the function as it keeps going forever to the left. We're going to focus on solving these limits to infinity for polynomial functions and rational functions. But first, we need to be able to spot whether we're dealing with a polynomial or a rational function, because the method we use to solve limits with infinity depends on the type of function we've got. A polynomial function is when we have no fraction, or when there is a fraction, but there's no x in the denominator, meaning no x under the fraction. And a rational function is when we have a fraction with an x in the denominator. Basically, there's an x sitting under the fraction. All right, let's start with polynomials first. How do we solve limits to infinity for polynomial functions? This one's actually the easier of the two, because all we focus on is the term with the highest exponent, the biggest power of x. That means, in this example, we'll focus on the first term because it has the highest power of x. We're simply going to ignore all the other terms. They don't matter for this type of limit. Let's take this one as an example. First, we can see it's a limit that tends toward infinity, in this case, negative infinity. Second, we can see it's a polynomial because it's just an expression with no fraction that has an x in the denominator. So how do we work out the limit? We only focus on the term with the highest power of x. In this case, that's minus 5x to the power of 3. This part is super important. Whenever we're working with a polynomial where the limit tends toward positive or negative infinity, the answer will always either be positive infinity or negative infinity. So all we need to do is figure out whether the answer is positive infinity or negative infinity. How do we do that? We simply substitute the infinity from the limit approach in place of x. In this example, the limit tends toward negative infinity, so we replace x with negative infinity. Now, all we need to do is check what the sign of the answer will be. We only focus on the signs here, so a negative raised to the third power will still be negative. Then we multiply that by another negative in front of the bracket, and two negatives make a positive. Remember, for polynomials, the answer will always be infinity. Our only job is to figure out if it's positive infinity or negative infinity. The actual numbers don't matter, because think of it like this. Infinity basically means a really, really big number. So even if I take that huge number and multiply it by 5, it's still just a huge number. Infinity stays infinity. So for this polynomial, the answer we got is positive infinity. And just like that, we're done with the limit. So to quickly sum everything up, when you've got a limit that tends toward infinity, it's either going to be a polynomial or a rational function. For a polynomial, we know the sum will have no fractions, or if there is a fraction, there's no x underneath the fraction. What do we do with these limits? We only focus on the term with the highest power of x. That's how we figure out the sign of our answer. Important to remember, a polynomial limit to infinity will always be either positive infinity or negative infinity. So your only job is to work out the sign of the infinity. Easy as that. Now for our second type of limit to infinity, called a rational function. How do we spot a rational function? Easy. There's going to be a fraction, and there will be an x sitting underneath the fraction. So how do we handle these types of limits that tend toward infinity? We use a method called the chocolate sharing method. Let me explain how that works. If you've got one chocolate and you share it with your friends, you know, the more friends you share it with, the smaller your piece gets. That's exactly why we don't just hand out chocolate to everyone. Now imagine you share that chocolate with everyone in the whole world. Your piece becomes so small, it's basically nothing. And that's the exact same principle we use to solve limits to infinity for rational functions. So, mathematically, we can explain it like this. When we do a chocolate share, we're basically doing a division sum. And a division sum is nothing more than a fraction. So, if we share that chocolate with an infinite amount of people, we know our piece of chocolate gets so small that it's basically nothing. It practically disappears. The same thing applies even if we're sharing more than one chocolate with an infinite amount of people. The principle stays the same. The piece of chocolate you get is so tiny, it's basically nothing. To sum it up, if you divide any number by infinity, the answer is 0. We're going to use this exact principle to solve rational functions where the limit tends toward infinity. Let's take an example to explain this. First, we can see this is a limit that tends toward infinity. Second, we can see there's a fraction with an x in the denominator. So this is a rational function. So how do we use the chocolate sharing method to solve this one? Let me show you. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.